And of course, you can stay with us as you wish. And we are going to move on with the agenda today. And we are going to start the session of contributed papers. We are going to have 2 papers in this session, and there will be a panel that we can cover things related to this and perhaps some other things of even the previous presentation. Okay, Vahid is already there, sharing his screen. So this is joint work with Sebastian Stein and Rick Gardin and Mick Jennings. So please, the floor is yours.
So, hi everyone, this is Vahid Yazdonpana from University of Southampton. And this talk is mainly about applying the strategic reasoning for accountability ascription in multi-agent teams, the joint work with Sebastian Stein and Enrico Gerding from Southampton, and Nick Jennings from Imperial College London. I have to say that it's not a technical talk, so it's mainly just an attempt to attract the community to focus on responsibility reasoning, how we can formally discuss responsibility and its like task-oriented variant, what we call accountability here, as a step towards trustworthy AI. So I will start with just talking about what's responsibility, then very informally talking about our formal approach. We use ATL, alternating time temporal logic, and then linking to accountability, and finally open problems and some discussion points. So we could actually start with the Uber case. So the Uber case took place, who is accountable, who is responsible. But as we are somehow, at least virtually in Montreal, I'm going to tell you a story, a kind of fictional story. It's, you know, some of the characters, but some of them have like fictional middle names. So it's something from French Revolution. So you know Jean-Paul Marat, and you probably know some of our other characters here. Napoleon Bonaparte with N, Madame Elma Roland. So we have some fictional middle names just to use N, E, W, and S. So we have Madame Elma Roland, Marcus William Lafayette, and Charlotte Chanton Cordy. So here these are like main characters of our story, and we have Jean-Paul Marat. So there was a party, dinner, drinks, and capable agents. Some of them use their power. And in this case, we have that someone realized he is poisoned. So in this case, you know, fictional story, Marat is dead, but here he is poisoned. So in such multi-agent settings, responsibility reasoning is about knowing who is and to what extent they are responsible. And then whether we can also see them accountable. So what's the relation here between responsibility as a, let's say, more basic notion in relation to accountability? To be able to discuss this notion and more reason about it formally and as a base for linking to computational techniques, we need to capture various dynamics of responsibility and its task-oriented variant notion of accountability. First, we are not talking about responsibility as like, I'm a responsible person. It's not a kind of general notion. We are talking about responsibility for a given state of affair. And that state of affair is normative. So it's either a desirable one, undesirable one, in some cases a neutral state of affair. So here, for instance, this S is death of Marat. Then it has a strategic aspect. So which agents or agents group were capable of affecting the occurrence of S, whether it's ability to avoid it, ability to ensure it, or the control ability. So being able to either ensure or avoid. Then epistemic dynamics, what knowledge, what information was available to agents, and in some cases is available. So it's kind of both perspective and retrospective perspective on knowledge. And finally, temporality. I may be responsible now, but not a week ago or a week from now. So you see that this kind of responsibility reasoning and formalizing responsibility, it has various dynamics. And looking at these different dynamics, you will have different forms of responsibility. The first distinction is backward looking versus forward looking. If you look at That's a more or less, in most cases, we are talking about backward-looking responsibility. Something already took place. We want to know who is responsible for that. But there is also a notion of forward-looking responsibility, which is more or less a kind of planning and task allocation. We are planning a picnic. I'm responsible for food. You're responsible for driving. So it's more or less using this notion of responsibility as that you're tasked to do this. But in this talk, I will focus on backward-looking responsibility. Then individual versus collective responsibility, whether we can see collectives as responsible entities. It's still a kind of hot topic, but here we are following Michael Batman's perspective that collectives can be seen as responsible agents based on his work on collective intentionality and collective agency. And then responsibility versus task-oriented accountability. Who could avoid it? Who were tasked to avoid it? And following the second point, like collective versus individual, if we ascribe responsibility to groups, whether group members are similarly responsible, whether we can like share it uniformly, or can we see some group members more responsible than others? So this responds to this problem of responsibility gaps. For instance, if we have autonomous vehicles in an intersection, you have a crash. Can we see all of them responsible similarly, or can we say that you are more responsible than the other vehicle? If we want to go further and like define conditions for responsibility, first of all, we have to just focus on S-relevant histories, meaning that we are just looking at history of events that end up in that state of affairs. We are just excluding other possible scenarios that in which S didn't happen. Then we will find agent groups capable of avoiding that S. Then a kind of technical condition here is minimality of that group. We want to look at just core set of agents capable of precluding. And if we want to link to accountability, they should be actually tasked to do so. Till here, 1 to 3, they're just about responsibility. But then if we want to look at accountability, we need to also see allocated tasks. And I have to clarify here that when we're talking about strategies as like chains of actions, we can use some notions of strategy, for instance, uniform strategies in alternating time epistemic logic, so it will be ATEL, in which strategies are bound to epistemic limitations. So actions are available to agents under their epistemic limitations. I'll not go through details of like this semantic machinery, concurrent epistemic game structures in which we have a set of agents, a set of states, actions, and then indistinguishability relations that clarifies what knowledge is available to agents, and then the transition function. So there's a way to formalize, details are in the paper. If we use CEGS, then we can like formalize what we discussed here, that how we can find out capable groups capable of avoiding this undesired situation, and then checking their minimality. And for accountability, also checking the task allocation. Going back to that story, based on our investigation of the case, we know that N had like a poison pill with 1 gram of poison in it, E with 3 grams, W with 3 grams, and S with 5 grams. And we know that they all released their pill into Marat's wine. So they were serving, and then they released their pill. As you see here, it was a kind of clockwise order. So first, N and E had the chance to release their pill, and then W and S. But they also had different types of pills. So we are just introducing these dynamics to make it more, let's say, realistic. They have power, but they have different types of power here. And we know that blue and red cancel each other, meaning that if you have like 1 gram of red, 1 gram of blue, it means like you have nothing. And then 4 effective grams of each kills. So if we just apply our formalism here, we will have such kind of diagrams in which we have states like green states and red states like death states. And then we can find out that we have 4 minimal groups responsible for this death, meaning that all of them, all these for minimal groups were able to avoid this step. They had a strategy to do so under their epistemic limitations. And so we discussed before that if we are seeing groups as being responsible, then we need a method also to share responsibility among group members. If we look here, we see that S, Shanton, is a member of 3 responsible groups. So probably we are expecting S to be more responsible. So here, when we apply Shapley value here to distribute responsibility, you can see that 3/6, Shanton is responsible, but others get 1/6. And if they were also tasked to protect Marat, we can also see them accountable. So not far from responsibility in autonomous vehicles. For instance, here, if you go back through the history, we have different agents here, Uber car, Tesla car, bicycle, but we also have agents capable of epistemic actions, the light here. So just 2 open problems. I think I have just 10 seconds. Here, we are just seeing agents with a strategy as being responsible, but their strategy can be different. So complexity of the strategies, it's a work that Politècnica and others are working on. So whether the strategy available to agents is a hard one or easy one. Then thinking about credulous and cautious situations in which an agent group is responsible under one scenario, but not all scenarios. And finally, responsibility under norm conflict, situations in which avoiding something may cause another harm. We are focusing on this in 2 projects, Auto Trust, which is more or less focused on Internet of Vehicles, and also the Task Hub, Trustworthy Autonomous Systems Hub, in which we are focusing on various aspects of responsibility for tasks. Some discussion points, but I think we don't have much time, maybe in the panel discussion. How we can reason about responsibility under flexible autonomy is an interesting one for me. In situations where agents sometimes are autonomous and sometimes are acting under control. Thanks for your time. Maybe we can discuss in the panel discussion.
Thank you, Vahid. Maybe at the end of the session, if we are out of time, you can calculate the Shapley value of each of us and who's most responsible, the chair or the participants, for the delay. Okay, let's move on to, I think there will be plenty of questions. I have some, but let's keep them for the panel. And let's move to the next talk. I think we have Will around. William, yeah,
yes,
Will, you're there, yeah. Okay, you can share your screen and start. This is joint work with Roman.
Yes.
Okay, go ahead. Thank you.
Yeah, so thanks for coming to this talk on the impossibility of unambiguous communication as a source of failure in AI systems with myself and Dr. Roman Yampolsky. So it's 2021, and we know that we have an increase in NLP-based AI systems in consumer electronics. We have things like Amazon Alexa, Google Now, and of course, chatbots that are becoming increasingly prevalent. But because of the natural language-based input control systems of these electronics, we see a unpredictability issue that could come from these systems. And for that reason, we see natural language as a poor input control mechanism for these systems, as well as advanced AI and safety critical systems. So sidetracking off into linguistics a little bit, if we look at linguistic theory, we know that linguistic theory can be broken down into these interfaces where you have things like sounds and phonemes and morphemes, where each interface, a good understanding of one interface is required for the next. So a system would have to understand sounds to be able to process more phonemes, and then phonemes to understand morphemes. This is sort of the linguistic conception of that. And humans, of course, have a very intuitive understanding of all these different levels of analysis. And accordingly, humans can process and disambiguate any ambiguity that they might find in many of these different linguistic interfaces. Current NLP systems, unfortunately, cannot do this. And this is sort of where this issue of ambiguity arises. Sidetracking again off into the idea of end-to-end approaches in AI. I've provided 2 examples here. One is a company called Comma AI, which produces a self-driving car system called OpenPilot. And I've quoted them saying that an end-to-end approach will solve self-driving cars. And then I've also referenced OpenAI's GPT-3 system, which is, of course, a very large language model, which is trained to predict the next word in an end-to-end way. And both these systems opt for getting rid of handcrafted features and feature engineering, and instead move towards an end-to-end system where the crux of the system is really the data and the architecture. So because of this, they're able to improve on their benchmarks. However, they do end up sacrificing some degree of explainability, predictability, and interpretability. So in terms of NLP and NLU, natural language understanding, we want our AI systems, as they approach human level understanding, to be able to disambiguate along these different linguistic levels of analysis that I'll get into shortly. But our current systems do not have this ability. So there's sort of two-pronged approach here. So as our systems approach NLU, natural language understanding, they're going to face a lot of issues with unpredictability, unexplainability, and they'll have failure modes related to that inability to disambiguate natural language. But then once we have systems which achieve natural language understanding, they'll be able to be used in different ways to manipulate and influence using that same ambiguity that's inherent in natural language. So just to look at one example, which is syntactic ambiguity. Take a sentence like eliminate the target with a bomb. This sentence could have implications for military AI or weapons-based AI. Not that we endorse that use of AI, but so looking at the example further, you could have an AI system, which is the robot, and then it's given this command, eliminate the target with a bomb, and on the left-hand side, it could interpret that to mean that the target is in possession of a bomb. Whereas on the right-hand side, that same system that same sentence could be interpreted as eliminate the target by means of or using a bomb, and that robot may have that bomb as its own weapon that it can use. Now, in linguistics, this is actually analyzed using syntactic trees or parse trees, where the structure of these trees is what determines the interpretation. So on the left-hand side, the details aren't super important into the theory of this, but you have a verb followed by a noun phrase, which is the NP there. And the noun phrase is that right node of the verb phrase, which is the root node, is a constituent of its own, right? So the target with a bomb falls under that single noun phrase node. If you look at the tree on the right-hand side, though, the structure is different. So the root node is a verb phrase, with a left node being a verb phrase, eliminate the target, and the right node being a prepositional phrase, that's the PP node. So because of these two structures, that's how we get the interpretation under this theory, the interpretation from the slide before. So crucially, though, this type of symbolic reasoning is exactly what our current NLP systems are not capable of. So one way that you might be able to address this type of ambiguity would be to opt for a different type of coding scheme in your natural language. So there's something called prefix codes. The code on the left is a code which transitions a letter of the alphabet into a numerical code. The code on the left is actually a prefix code, so it's unambiguous. The sequence ABC can be converted to 10100, whereas the code on the right-hand side actually, if you try to convert the letters ABC, you can convert this into 1100, or and that can be parsed in two different ways. So that's one thought. You might be able to use an unambiguous type of language or an unambiguous type of communication. However, this is really only addressing one of those linguistic levels of analysis, the syntactic. So if you look further, you have phonological ambiguity, which is also rampant in language, and of course would pose an issue for our speech recognition systems. You could have a sentence like the tail of the dog, where tail is spelled T-A-I-L, or the tail of the dog T-A-L-E, which is a totally different idea. So those are the problems that we're going to run into with our current AI systems, which really lack natural language understanding and that ability to disambiguate in a human way. But then in a system with natural language understanding, which would obviously be a more advanced system, that system is going to be able to generate, using an understanding of language and ambiguity, ambiguous news headlines, as well as ambiguous legal documents, software requirements, and contracts between which legal documents with ambiguity, which could pose a large issue for the business community and legal entities. And then, of course, these systems could be deployed as bots or web agents in a malicious way. So to sum it up, the safety concerns again are at present that lack of explainability and interpretability for these brittle AI systems, which lack NLU and are largely based in neural network approaches with large parameter counts. Now, neurosymbolic AI may help bridge that gap towards natural language understanding and help systems gain the ability to disambiguate ambiguities in language, thereby sort of reducing that failure mode. However, as we discussed, that NLU capability could then be turned around and used by bad actors or released onto the web to deleterious effects. And that's everything. Thank you very much.
Thanks, Will, for the presentation. And so now we can and just keeping the time. So we now have about 15 minutes, I think, for discussion. So typically, we try to organize this as having one or more discussions, just throw in questions, but at some point, even sometimes at the beginning, we welcome questions from the audience. So our session discussion today is Gabriel Pedroza. Are you there?
Yes, here I am.
So
good morning.
If you have some general questions or specific questions, you can start. Maybe at some point we can you can just highlight some common points of the session so far. Or
just to mention,
it's up to you just to make this. Yeah.
Just to mention that Chen also accepted to be discussant. So.
Sean that's true, there. Sean, you are there as well. So yeah, I missed that. Probably I'm using an old version of the program. Yeah, now it's updated. We'll update this. Okay, so it's your floor. The floor is yours. I will coordinate to find some questions, but you can start the discussion with the presenter.
Hello, Sean. Probably you want to start the discussion if you prefer.
Sure. So the first thing I would say is to the audience, please do pose questions, raise a hand, or put a question into the chat. Because there hasn't been time for questions after the talks, we'd be very keen to take questions now. I have a couple of questions of my own. First of all, just to say, these were two fascinating talks on two very important topics that are sort of rapidly coming to being practically relevant. The first talk, I think, did a very important thing in kind of really breaking down the interplay between responsibility and accountability, and looking at the angle of multi-agent systems is going to be critically important, particularly as we bring, whether it's self-driving cars that may interact with other agents on the road, or a lot of the other contexts in which we have systems interacting with each other. Questions of responsibility and accountability become a lot more complex and are critically important. So this is a very important topic. The second paper, I think, is equally important. We've seen, especially in the last 1 to 1.5 years, a real set of advances in things like prompting systems and in chatbots, both of which highlight how important it is to phrase questions and phrase inputs in quite a specific way, and how this kind of can constrain us and how it can go wrong. And as we develop systems that are more capable. It seems to me that we're quite well, maybe I'm wrong about this, but it seems to me that we're quite a long way from systems that have proper, like, full natural language understanding as we'd understand it from humans, because this requires such a deep understanding, not only of language and linguistics, but of the world around us and what concepts relate to. And so this question of ambiguity is going to become even more important in that middle area where these systems become more useful, but are still short of that human level of understanding. So I think that the questions being raised by these papers and the analyses are both timely and important. So that's a very brief response. A question that I wanted to pick up on was one that was in my mind, and I noted that the first speaker did raise it towards the end of the talk, which was this question of, well, what level of responsibility can you have at different levels of autonomy? So if we're thinking about something like self-driving cars, we're now familiar with the idea of thinking of different levels of autonomy. But I mean, can you really have a system that's properly responsible if it is not fully autonomous? And the talk raised the question, are there useful categories of graded responsibility, partial responsibility? And I'd really like to pick up on that and ask the first speaker to elaborate on their thoughts on this, because I think it's a critical question.
Thanks for the question, Sean. In regards to the first part, like whether vehicles can take full responsibility. Basically, like when we are talking here about using a strategic reasoning for responsibility ascription, and as like we had in this example, they have different levels of power, different levels of power with respect to that specific situation. So first of all, for instance, if you're talking about this crash among some vehicles in an intersection, different agents have different power. So for sure, if a vehicle is not that autonomous, let's say, so it has like level one, if we follow this level 1 to full autonomy, then they have different power with respect to that crash. So if a vehicle, and in most cases, not only one agent can preclude the situation. So most of the time, a collective will be responsible. So we see that neither of them will be able to fully avoid that crash, but a group is. So that's why we started with looking at collective responsibility from the beginning. In most cases, we cannot find a single agent or a single vehicle capable of avoiding that undesired situation. So that's why we are starting with collectives and then finding ways to share responsibility among group members. And so if we go for this, the second part, like flexible autonomy, agents that are in some point in time, they are under control, and in some points they have a level of autonomy. Then because we are thinking about responsibility as a kind of temporal notion, then we are able to ascribe responsibility in different states and different responsibilities in different states. So I, like, my response would be, first of all, looking at this as a collective notion, solve this problem of like less autonomous vehicles in the system, and then temporality of the notion of responsibility. So both collective responsibility and temporal aspect of responsibility to some extent addresses that problem.
Okay, probably I can highlight two interesting points I have identified from the previous discussion. One is the fact that we understand that natural language is indeed ambiguous, because human behavior, human activities are or can be also ambiguous. And then to deal with that, we are trying to integrate this kind of formal languages. And the introduction of those formal languages is usually to address that ambiguity. But we know that as long as we introduce those formal languages, we are losing some kind of natural speaking. We are trying to align something which is typically human to something which is not really human. For instance, when we introduce formal languages, we can lose expressiveness. So there is this trade-off between natural language and formal specification of that language. So the question there is if there is the possibility to handle both. If there is a kind of good metric we can introduce to settle that trade-off. And that's my point there, especially considering because on one side we have a paper claiming that we have unambiguous communication. We cannot get rid of unambiguous communication. And on the other side, we have a paper claiming that we can have this kind of responsibility of agents to develop, to conduct some task. So I have a question, for instance, for the second presenter. If it is possible, for instance, to develop an artificial intelligence that can develop its own language to get rid of that ambiguity.
Yeah, that's a great question. And I think that might be possible. A system could have an internal language that it could use to communicate with other similar systems or itself. But at that point, I'd be concerned that maybe that internal language the system would be using might not be interpretable or explainable to human operators. And there would be a question whether humans would be able to interact with that system in a natural way, right?
Yeah, and there probably we can start to discuss about the risks that imply, because probably machines can communicate between them without any ambiguity. But probably what's at stake are the risks that that kind of communication between machines could imply if we don't have the explainability, the sufficient explainability to humans, right?
Right, I agree.
So then if we have clear the objective, if we agree on that, so what's missing? So the interesting question to me would be what's missing? What's missing to have a good trade-off between the perfect, let's say, communication between machines and the sufficient explainability for humans? And of course, this is an open question. So if someone wants to react to the question, please go ahead.
Yes, maybe here, Leon Castro. I had a question for the other for the responsibility, but I think also in this context, paper we have now is also related to that. So if you have, in my opinion, if you have ambiguity in the text, the only thing, I mean, this is an intrinsic ambiguity. So I think you can never resolve that from the text itself, or even from any intrinsic background information. The only thing you can resolve it is looking at the context in which this text, or in the context of other text before that or after that, or in the context of the situation, this sentence is being used. So that relates to our paper, because what we actually say is that a text only makes sense if you can really see any human understands it as a better explanation of the situation at hand. Basically, you can never resolve an ambiguity in a sentence from only the sentence itself, because that is impossible. You can never say this is the good interpretation or the other one if you do not have other information, either from text before it or text after it, or from the situation in which you know this text is being uttered, what the good interpretation of this text is.
So regarding what you are saying, to me, this is as complex as the question about the possibility to write unambiguous requirements. If
Exactly.
it is possible.
Yes.
Yeah.
It's exactly related to that. And that is also relates to my other remark to the other talk. So first question is responsibility. In our work, we make a distinction between who is responsible for the working of the AI, the problem-solving capability of the AI, the optimizing capability, problem-solving capability of the AI itself, and who is responsible for specifying the purpose of the AI. So we argue that AI can learn a lot of things, but it cannot learn human purpose. So it cannot learn what is good or bad in terms of ethical representations. So in the solutions we advocate, we actually say, well, there are two types of responsibilities here. One is in the working of a good AI, and the other one is a responsibility to specifying good purposes of the AI. It's basically the same as with law. I mean, you have people who make systems, and you have other people who specify what is lawful and what is not lawful for these systems to do. And these are different responsibilities. So the question is actually, what type of responsibility are you talking about?
Yeah, I had actually one question for clarification. So here you're defining these two as two serial problems, right? Responsibility for a specification and then for operation, let's say. Am I understanding it right?
Yeah. So one is responsible basically for specifying the rules under which these systems work, or the utility function, or the objective function, or whatever you like to call it. So you have a challenge in specifying that, and somebody should be responsible for that, for specifying that. And you have a responsibility for developers to optimize on this function, which is a different responsibility, because the one is a responsibility of making a system that acts according to these norms and rules and specifications. And there's another responsibility of specifying these rules and norms in the first place. This is what we call disentanglement of responsibilities. So this is where we write papers about. It's very important, in our opinion, to disentangle these two types of responsibilities.
I have a sort of engineering question related to this, and it's related to, I mean, in the short term, you know, as we start deploying these AI systems, for example, in the DoD has requirements on traceability. I mean, the US DoD. So the question I have is, we want the systems to be auditable, right? To be able to assess, you know, let's say after the fact, let's say on the spot, maybe we're not able to you know, uphold, requirements or design intent, but then maybe after the fact, at least we want to learn from our mistakes. And so what information needs to be recorded, right, to make the systems auditable? So what are your thoughts?
I could answer, but maybe
maybe.
Okay, me. So that's quite clear to our understanding. You cannot evaluate, or you cannot even trust the system if it's unclear what its purpose is. So if you did not specify well enough, and there are some people who argue, and we saw it in previous talks also, that we can say, well, we can learn also certain things, what could be good or bad, we can learn that. And what we argue is that you could learn by induction, which is basically meaning, okay, if you already have a good evaluation, knowledge representation of your evaluation setting, you can improve, you can refine that. But the real problem is that we have to address, and which is currently almost not addressed at all, is what is actually a good knowledge representation to do your evaluation. So basically, it means what is a good mathematical representation of how we could evaluate something. It is known from, very well known from the development of advanced AI, that you can only optimize, like on the papers on partnership of AI, Peter Exley, for example, you can only say that you can make a system. As a system engineer, you can only make a system that it's unambiguous in which it is optimizing. And if we also know that AI cannot learn basically good or bad, it can learn to tune the values, but it cannot learn to understand what the values actually are. The representation of the values, it cannot learn. Because for that, you need knowledge. You need actually to create new knowledge, which AI currently cannot do. It's also in the talk, the Facebook talk. Current AI cannot do this at the moment. So if we know that, the real challenge, in our opinion, becomes, what is a good knowledge representation to evaluate advanced AI? And it has to be a human constructed representation, because AI cannot learn it. AI cannot generate it. So we need to have this knowledge representation from our human capabilities. So this is a very deep and important problem to address, and we try to do that, but it is a very challenging one. Yeah, it's basically also at the core of the problem of human language, because basically to really understand human language, and also again that is related to the Facebook talk, to really understand language, you need also to understand good or bad. But we know that current AI cannot understand good or bad. And we also know why it cannot understand good or bad. So we as humans are still in the driving seat to somehow try to understand how to represent in mathematical terms basically harm. To our understanding, we cannot at the moment, maybe in future AI, because we also think that in principle there could be AI in the future which is able to do that, but currently not. And so therefore we currently have to think of who is responsible for actually coming up with good representations for evaluation of this AI.
Okay, we have some questions. I don't know if the panel would like to invite some of these questions to be, there's one from Will but maybe there's some other questions before that. It's up to you, Sean and Gabriel, just to decide.
Yeah, I probably we can give floor to those questions. There are two questions indeed. The first one is from Bahid. It's related to, probably you can intervene, Bahid, again.
Yeah, that was actually like a conversation and in response to previous discussion. So the idea that was discussed is very much close to this idea of ethical black box by ECSEL and Winfield. I was actually looking for the paper to send a link. That robots need kind of ethical black box. Here, black box not as machine learning black box, but like in aviation black box. So that's like in response to the suggestion that we need autonomous vehicles or autonomous agents to have a kind of ethical reasoning engine as well.
Okay, then there is a question from Will. Probably he can directly address the question.
Yeah, so I understand that the first presentation is on assigning responsibility to AI systems, and usually in order to assign responsibility for an action, in humans at least, there's an assumption that there's free will for that agent. So are you able to draw an analogy with sort of assigning free will to an AI system?
That's a question addressed to Bahid.
Yes.
Yeah, Bahid.
Yeah, so the point here is not to see, let's say, a bunch of wires and metal to see the vehicle itself as being responsible. But for instance, in the context of autonomous vehicles, when we're talking about moving from owner responsibility towards manufacturer responsibility. So the point is not that the vehicle itself being responsible, but when we want to reason about manufacturer responsibility, we should first of all find out which vehicle was the most responsible in a crash, let's say. So that's an attempt to find out which vehicle is the responsible one, and then moving further towards the manufacturer responsibility. So if we want to move from owner to manufacturer, we at least need to understand which vehicle is the most responsible. And then its manufacturer or its designer, it will be the most responsible one in such cases. So it's not the vehicle itself I'm referring to.
Oh, great. Thank you.
I think at this
okay.
point, I think at this point
go ahead, please.
Yes, we should wrap up because we have the poster pitches coming up. Thank you to all the speakers and all of the audience who asked questions for a really valuable discussion on two very important papers. Please do join us now for the rapid poster pitches before the afternoon session. Thank you very much.